Hi guys, and thanks for stopping down to Pete's Garage. Well, it's time to put our cylinder heads on, bolt them up to the engine, but before we do that, there's a couple things that we have to do. First, we have to choose a head gasket. So what we're going to do is we're going to talk about head gaskets, a different type of head gasket, and how to measure to make sure you're going to be purchasing the correct gasket. We're going to do that with a set of, we're going to do a digital depth gauge and some micrometers to check to make sure we got the right gasket. That's how we're going to choose the gasket. Then we're going to go through how to use the gasket to make sure your head is ready and how to make sure the block is ready for the installation. Now, these cylinder heads are all ready to roll. I've painted them with the same paint I used to paint the engine, the Eastwood Ceramic 2K ceramic paint, which is an excellent paint. I like the way it works. I like the way it looks. These heads, in case you haven't been following, have been ported and polished in a previous video, and I have gone through many discussions about porting and polishing the intake runners on carbureted versus fuel injection engines. So that's an interesting conversation if you want to go look at that. But this engine features a lot of things. They have stainless steel valves, a high temp stainless steel valves with 3-angle valve grind, comp springs, high pressure, positive seated valve stem seals, titanium valve caps, the caps to reduce the motion and the mass of the spring so it returns quicker. And I poured it and polished the whole thing, painted it, and it's all ready to roll. So we're going to talk about the gaskets. We're going to get ready to install it. We're going to talk about head bolts a little bit. Should you or should you not lubricate, and what happens when you do put lubrication on a head bolt. We'll put the lifters in. We'll put in the push rods. We'll talk a little bit about push rods. Then we'll put the rocker arm studs in. The rocker arm studs goes in with the adjustable guide plates for the push rods that go up to the lifters. We'll talk about those. I'm going to talk about something called latch caps. Latch caps are an interesting thing that'll help you gain a little bit of space for your rocker arm, and I'll show you why I had to use them on these heads right here. And then we'll talk about the rocker arm installation itself. We'll go through setting the lash for hydraulic, as well as if you're going to use a solid lifter or solid tappet engine. We'll go through that lash. I can still do it with this lifter even though it's a hydraulic roller. I can show you how to set that lash. So let's get started. Let's talk about head gaskets, different types of gaskets, and how you should choose your gasket. Now, the first thing you have to consider when you're purchasing your head gasket, it should be part of your overall plan when you purchase the parts, including the piston. And this is why. The piston has on it something called a quench, the quench band of the piston. And it's very important to know what that quench band is and what the quench is going to do. The turbulence from the combustion in this chamber all has to go somewhere. And right around the outside here, this flat area is considered the quench area, or the squish. This is where quenches are squished. The quench of the band, right here, the quench band, what this does is it forces all of the mixture of air and fuel and the exhaust, it forces it towards the center of the piston or towards the center of the chamber so that it either can suck it in evenly or it can push it out of the engine evenly. So the quench band is one of the considerations when you're building an engine. Ideally, a flat top piston with a good quench band is going to get you an even more heave and heat distribution. Now if you're using a eutectic, hypo or hyper-eutectic piston, it all comes into play. But when I built this engine, I decided to go with this particular piston, and I needed this valve clearance for the amount of lift I'm having on my cam. And I chose this piston because if you notice on this side, it's got a little relief cut in this valve, and these relief cut for this valve, and on this machining on this side, since the quench band is so small over here, this allows the squish or the quench of the combustion and of the air-fuel mixture to flow towards the center of the valve here and cause turbulence. So it's going to flow this way. As the piston comes up and this part of the piston gets towards the cylinder head, it's going to squish everything towards the center, and you'll get more complete combustion. And that actually has a lot to do with horsepower and emissions. Usually a dome piston will be used for emissions. You have a dish piston like this required for horsepower, but this is an important part considering when you buy your cam and if you're going to have clearance for your valves. That's number one. Another consideration is the type of engine. Are you going to have a naturally aspirated engine? Is it supercharged, nitrous, and so on and so on? It can be said that the Comtech MLS or multi-layer gaskets, like multi-layer steel gaskets, although they're expensive, they negate the need to have an O-ring sealing surface out here. But we'll talk about that when we talk about gaskets. But first thing I want to do is to know what thickness gasket I need. Let's measure the deck clearance of this piston, and I'll show you how to do that real quick with a depth gauge. Okay, so let's check our head deck clearance using a digital depth gauge. Now, piston 1 is at top dead center. There's a couple ways you can do that. You can do that with a magnetic base and a dial indicator to make sure it's at top dead center, or you can do it the old school way. You put it there, you put your depth gauge there, measure once, turn the crank a little bit one way, turn it the other way, and get a happy medium and make sure it's at top dead center. But I have this piston set at top dead center. So what I'm going to do is I'm going to take my depth gauge like this. I'm going to put it on the flat part of the block, and I'm going to make sure I hold it completely flat on the block. I'm going to make sure that it's all the way down, flat, and I'm going to set my 0. Then I'm going to move over to one of the quench ring, and I'll push this down. And I got 7.5 thousandths or 8 thousandths right there on this measurement. And I'm going to take a couple measurements here. I'll do it again. I'm going to push it down and make sure it's flat. Got our 0. I'm going to move over to the quench band, push it down. I got 8 thousandths again. Now I'm going to take another measurement here, but this time I'm going to do it out here on the quench band. I'll go out here and measure and make sure I'm on a flat spot of the block. 9.5. So I got a little bit of difference in the piston here. Let me go on this side. I'll measure it on this side. Get this zeroed out. Move over. I got 6 thousandths over here. So I have 8.5 thousandths, 8 5/10 over here. So I have between 5 and 8, so we'll call it 7 thousandths. Let me just measure one. I'm just going to take one just to make sure. I'm going to take one at the top here, at the top of the piston. Get it across 2 flats. First, let me set it at 0. It's at 0. Get across here. I'll go across the heavy part. And this measures up here at roughly, let's see, 17 thousandths. So there's a, I suspect that the piston is probably rocked in there a little bit, but let me take one more measurement, one final one, and we'll go with that. 12. So we got 12 down there, 14 up there. So we're looking at about 12. So you can never be too sure. You got to take a lot of measurements. Got 16 one way. 9. So the piston will rock in there very, very slightly. So I got 12 there. I can get it down to 9 by rocking the piston. I can take this side over here and I can get this from 14 and get it down. So I'm going to say my overall deck clearance, the smallest measurement I had was 6. So I'm going to go with 6. 6 thousandths head deck clearance because the piston will rock in there, and it can get down as low as 6 thousandths clearance. So I'll go with 6 thousandths on the piston to the head deck clearance. Okay, now let's talk about the different types of head gaskets. And there are many, many different kinds. I'm just going to go through a couple. The first is the most common type of gasket, and it's the kind of gasket I've been using in this engine. It's a layered gasket. It's actually a covered gasket, and it's sort of covered with this material. It's got these blue rings, which are the sealing surfaces for the water jackets and the oil return holes and the oil pressure holes. It's got a stainless steel ring, which is the fire ring, which goes around the cylinder. That's what seals the combustion chamber. And it's got some other seal here for around the dowel pin. And this goes up the pan rail, where it goes up to the intake area. This gasket, all gaskets actually are a single-use gasket. If you put a cylinder head on, you bolt it down, torque it up, and then you take it off, you should replace the gaskets. They're pretty cheap items. Yeah, some gaskets can be expensive. I mean, you get a Victor Wren's gasket or a real high-end gasket, could be $75, $150 a set, but they're really not reusable unless you get a specific gasket, racing gasket that's a multiple use. But for most part, for your most of the engines you're going to build, it's a single-use gasket. Take it apart, throw it away. It's really not worth it having a head blowout because you crushed the gasket when you installed it, tried to use it again, and it didn't seat right. So this is our first type of gasket. It's just a regular coated gasket with some rubber surfaces. These surfaces will melt when the engine heats up, and that will cause the sealing between the two surfaces. Luckily, on many gaskets, you might not have this luxury, but this gasket, you might be able to see right here, is marked front. So you know this goes towards the front of the engine, and that usually goes up. So you know when you put this gasket on front, and up. Not all gaskets are marked. Not all but then again, they don't have to be because they can only go on one way. They won't really fit on the other way. The other gasket, which is a little more complex, is a multi-layer stainless or multi-layer steel gasket like this. And these are truly a single-use gasket. Now, this gasket has, I hope you can see, this gasket has 3 different layers on it. You have the 2 crushed surfaces, and the inside one is your restrictor plate for the coolant and the oil. So this has 3 plates in it, this gasket right here. And this is a single-use gasket for one specific reason. And let me see here, I'll pick this up for you. Now, if you look really close, you can see that on this gasket there are embossed areas where the material is pushed up out of place. Now these embossed areas, this is a stainless steel gasket, so it's pretty hard, brittle hard. So when you clamp this down, these raised areas here are the thing that provide the seals. These are the parts that provide the seal. When you crush it down, these things, these raised areas crush, and that's what provides the seal. So this type of gasket, once you use it and take it off, it's spent because you crushed it once. So this kind of gasket is a one-use only. You can see it's sealed all the way around the fire ring and in between, whereas this gasket is not sealed around the fire ring. You can see there's a difference there. This gasket doesn't have sealing in between. This gasket does have sealing in between. So there's a different application for this. This happens to be for a 4-cylinder engine, so it's a little less compression, a little less. But actually, it's really not. This is actually for a turbo engine, and this gasket will see a lot of pressure inside the chamber, and things change. Now, the other thing that you have to consider is the materials. The block. If the block is cast and your head is aluminum, you're going to require a certain type of gasket. This type of gasket is more forgiving when you have a cast iron block with an aluminum head like I'm using. This gasket goes between an aluminum block and aluminum head where you have equal expansion between both materials and you have less chance of one expanding faster than the other, creating a leak. So this type of gasket is used for that sort of application. You can see that it's pop riveted together here. And one thing that's easy to see here is that in between, this gasket right here has no restrictor plate. It is as it is. This gasket is actually adjustable, not by you, but by the manufacturer, where they can take the same plate and they can change the inner restrictor plate. And you can see in the center here, these restrictor holes that are in the middle, right here, these restrictor holes have a smaller hole, and that's what restricts flow of the coolant through the engine. So you have restrictor plates that can either restrict oil flow or coolant flow around the engine. So you can see around the cylinder there's restriction of the coolant to try and keep the coolant there a little bit longer. And these type of gaskets are more expensive because they're 3-piece stainless coated and they're very precision. But then, again, these are only single-use gaskets. Once you crush it, you got to throw it away. So when you put it on, we're going to go through some checks you should do before you clamp down your head to make sure it's correct, so you never have to worry about pulling the head back off, changing your gasket, throwing away, because it can get expensive really quick. So let's go through. I'm going to show you what to do to check to make sure you have the right gasket, and what to check on your block and on your head before you clamp it up. Okay, now, the one thing you want to do is, and let me see if I got a whole good view. Okay, we got a good view here. Now, quickly about the machining process of blocks and cylinder heads. Blocks and cylinder heads, and hold on for 1 second. I have something over here I want to show you. In the machining process, when these parts are made, blocks and cylinder heads are manufactured by something called, in the design world, as absolute and relative dimensions. Since this is a 3-dimensional object, all of the dimensions on this entire 3-dimensional object are referenced from an absolute reference out in 3-dimensional space somewhere, so that they all reference on a 3-dimensional space during the design process only. When it's machined, there are machining locators on the block that, when it goes through the machining process, and it could be anywhere from maybe 10 or 12 to maybe 15 or 20 different CNC machines a block will go through before it gets machined. So it has to be machined and located from the identical relative positions. And in every one of those machines, let me sit down this dowel. every one of those machines is going to have something called a locator, and the locator looks something like this. This is a machining locator, and it's a very precision piece of equipment, and it's bolted inside the machine, and you'll have one for each side of the cylinder head or block or several depending on the part. And the absolute reference usually comes, and let me go down here and zoom in a little bit for you, goes from the dowel hole. The dowel hole on each side is where the absolute reference is from. So what happens is this block will come in, usually comes in upside down or sideways. It'll locate on this dowel, or this locator like that. And you see it's like a bullet shape on that dowel, or on that locator like that. The block will go in there, it'll clamp right against that dowel to make sure that it is clamped exactly in the same place in each machine. Then all of the features are machined relative to the position of the dowel. These parts right here on the block, I don't know if you can see that, let me make sure I can get that for you here. I just got a tripod, it's working out pretty good. I had a cat with 3 legs, his name was Tripod. Let me turn it down a little bit. Okay, we'll go through that again. When a block or a head goes through the machining process, it locates right here. It'll locate right on the locator when it gets to the machine. And this part right here is a clamp. A hydraulic clamp will come down, clamp the block in the same position. So this is a clamping surface, this is a locating surface, and all of the dimensions through the whole block are relative to the dowel position. So the dowel positions are very important when, after you've chosen your gasket, how you put it on there and line it up, okay? Now, let me zoom back real quick. I'm having fun with my little tripod here. Now, when you're choosing your gasket, you chose your gasket, you've decided what your quench ring is like, you've decided what kind of gasket you need. Do I need a stainless steel gasket because I have a high compression engine? Can I get away with this? This is a Felpro gasket, can I get away with that? Now, I measured the head deck clearance on my piston was 6 thousandths. You don't want to be less than 35 to 45 thousandths. So I got 6 thousandths here, which means I don't want to go below maybe 30, let's say I don't want to go below 31 thousandths for my gasket, 30 to 40 thousandths. However, I know that based on the calculations I did when I chose the parts, that I needed additional clearance for my valve clearance, and I wanted to add an additional 10 thousandths. So I got my 6 thousandths there. Let me grab my calipers, and we're going to measure this gasket, and we'll see what this gasket measures. I'll put this on here. Got my beautiful Starrett micrometers. You could use digital ones, but I like old school with the gauge and the vernier. This gasket right here measures 51 thousandths. 51 thousandths at the fire ring. So I got 51 plus the 6 thousandths of the deck clearance gives me 57 thousandths clearance when I put the gasket on. And that's very important because it's I know I'm using this as a spacer as well. So if you want to increase your combustion volume or lower your compression ratio, you can buy thicker gaskets, gasket spacers to pull the head further away from the block. As you pull the head further away from the block, the combustion volume increases, your compression ratio goes down because you're increasing volume. Okay? Now, I'll put that back down, and I'll put the dowel back in. My dowel. Now what you want to do is, I want to show you, when you take your gasket, after you get your gasket, before you put it on, before you put your head on, you just want to do a check. These are the checks we're going to do. I got my front, so I know it goes on this way. I'm going to sit it on my dowels. Okay? And I'm going to let it sit flat, just like that. You want to make sure everything's clean, lint-free cloth, no FM on the surface, no FM in the cylinders. Keep it as clean as possible. I know you're sick of hearing FM, but I'm going to keep saying it. So, we're going to put that on there. Now I'm going to look, and I'm going to make sure that, relative to my dowel hole, that all my coolant passages line up, the bolt holes line up, the oil return hole lines up, the coolant holes line up. A hole that's not being used, that was a restrictor hole, that's been sealed up. All my bolt holes line up all the way across. And, This is what problem I had. And this is very important. This is why I want to show you what's really important when you're installing your cylinder head and how to use your gasket to make sure that your block is ready. Let me zoom in on this because this is extremely important. This is a problem I had, which is why I'm rebuilding this engine in the first place. This is an oil return hole right here. Let me just see if I can get this perfect for you. This oil return hole, as you can see, you see how there's a little bit of metal there? Now I'm going to take this gasket off and show you underneath this hole. You see how that hole is oblong right there? This hole was not centered underneath my gasket. I had to sort of blend it this way, and I still have to blend it a little bit more. What happened here is this is a cast block, and although everything is machined relative to our dowel pins, this oil return hole, the gun drill that drilled this was probably off a little bit. It probably shifted in the casting, and my oil return hole was off. Now, what the problem I was having was these oil return holes were off by half, meaning that when I put this gasket on here, like that, half of the hole was covered up by the gasket because the oil return hole was off location. Now, they're not going to correct it at the factory because it's only an oil return hole, but in this engine, it's very important to have that lined up because I have a high volume oil pump. And with a high volume oil pump and the amount of oil that's being pumped to the top of this engine, it wasn't returning fast enough. It was backing up through the oil return hole, flooding the top of my head and getting through my valve seals. No matter how good the valve seals are, it simply can't block all of the oil that was getting in there. So, you take your gasket, you put it on there, you put it on your dowel holes, your dowel pins, and you check to make sure they all line up. I have a little bit more there I got to machine. I got to cut that down, make sure that there's absolutely no restriction when I put the cylinder head on the block. Okay, so everything looks good on the block. Let's put it on the head and see how it matches up. Okay, same thing for the mating surface of the cylinder head. Cylinder head's nice and clean. FM free. I've wiped it down. It's been stoned. I know this looks a little rough here, but that's where I've had the engine run before, and that's just a little pitting from the coolant I had in there that was running through. Again, cylinder head, three-dimensional object. It's machined or modeled from an absolute reference, but it's relative all to the pinhole. Again, the machining locator, which is in the machine, will sit here. There'll be one in each from each end of each dowel hole, and this is where the cylinder head locates when all of the features are machined, top and bottom. So they're all made exactly the same, and you can make sure all the features are going to line up. Now, the reason they didn't line up on the block is because the core shifted on that one, and had some of the core, if the core shifted enough where the locator hole was off, they would throw the whole block away. But I have a Ford block, I have a racing head, service head, and they're all going to make it from a drawing, and the drawing is made based on the position of this locator, just like that. So what I'm going to do is, I'm going to put my head dowel in here, not all the way because it'll fall in there. I'm going to put this on this side. I'm going to take my gasket, and again, towards the front of the engine. This is the front. Okay. And I see front goes this way. I'm going to put this on my dowel there. Put this on my dowel here. And it's slipped in, like I said, it's a little bit loose. So I'll do it the opposite way. I'll put it here and then I'll pop it through just to hold it in place. Now you can see how this is machined. And it's aluminum, so it's CNC machine is machined a lot better. You can see here that this, if I go over here, you know what I'll do? I'll take the camera. Let me pick up the camera here. It'll be easier for me to show you what I'm talking about. So we're off this relative hole. This coolant passage is slightly off. You can see that it's just a little bit off, but that's okay. I'm going to let that live. That's not going to be a big deal. I inspect over here. This coolant hole is lined up. My restrictor hole for coolant is lined up. Coolant hole's lined up here. Coolant hole's lined up. Restrictor hole is okay. Oil return, push rod hole, push rod hole, push rod hole, push rod hole looks okay. Those look alright. Bolt holes look alright. Coolant passages line up. They're going to be sealed. Locator hole's good. All around the fire ring, all of the rings look good. So, looks good. The gasket looked good on the cylinder head. I just have a little bit to touch up on the block, which I'll do before we put it on. No big deal. So, 6/1000 Head deck clearance on the piston on a 51,000 gasket, give me 57 thousandths clearance in here, right here in my combustion chamber, which is exactly what I need. It's more than 45 thousandths, which is good, and it gives me a couple extra thousandths clearance for these valves because I'm using a 1.7 rocker arm for this exhaust valve. It's going to open up a little more than regular 1.6, and I needed that extra clearance, and that extra 6 or 7 thousandths on the gasket is what allowed me to do that. Now, let me get this ready. I'm going to finish that block. I'll put the heads on, and we'll talk about head bolts. Okay, I fixed my oil hole here. Everything's nice and lined up, nice and cleaned out. Have my head gasket on. Everything is ready to roll. Now, before I continue, I want to remind you about number one piston being at top dead center. And a quick question is, how do you know which piston is number one? If you look this way at your engine, these two pistons, the front two pistons, if you were to line up the centers, one of them is going to be in front of the other one. Whichever piston is in front, this is going to be number one. And I found that true on almost every engine there, except for a straight engine, obviously, duh. But number one is usually ahead of the other piston on the other side. Number one piston. Now, if you recall, I set up number one dead center in previous video, and the crank is set up with the keys always up at 12 o'clock. So when the crank key is at 12 o'clock, piston one is usually at top dead center. I have my my gasket on here ready to roll. Now I'm just going to sit my block or my head in place. I'm going to take my head and I'm going to gently lay it on the pins of my locators or my dowels. I'm going to lay it down gently like that, and it's in place. I'm going to put one bolt in there just to hold it, just to make sure it doesn't move. I'll put the other one on, then we'll talk about bolts. Okay, now let's talk about head bolts for just a couple minutes here. First of all, if you are going to rebuild an engine and you're going to reuse your head bolts, and your head bolts are fastened using a torque and angle strategy, that means it's a torque to yield fastener, you have to throw it away. Don't even think about it, throw it away, get new bolts. Anytime you put angle on a fastener, you're taking that fastener, you're stretching it out to its yield point, and if you use it again, it'll stretch. Technically, theoretically, you can use it again, but you run the risk of stretching it and having a head bolt break, and it's not worth it. For 15-20 bucks for a new set of head bolts, replace it. However, if you go with a better bolt like these ARP fasteners, they're a little more expensive, 56 bucks for a set. Not terribly expensive, but they're more expensive. But the difference thing with this is it's a torque bolt. There's no angle applied to it, and this is a 180,000 psi hardened bolt. So it's going to apply a very large and even clamp load, okay? Now, these bolts came out of the same kit and they're both identical. The difference is they were both black, and I didn't want the short bolts on the outside of the head to be black, so I plated these bolts and polished them. And it looked like this. I sandblasted the bolt, I bead blasted the end of the bolt and the washer, and then I plated it using Eastwood's electroplating system. And it basically consists of an electrolyte solution. It's an acid that comes in a bottle, and you use a sacrificial piece of metal that you put in a bin, and you submerge the head of the bolt, and you put this inside, and you have it's an electroplating process where you have a ground and a positive, and in the acid the metal is sacrificial, so the metal breaks down and it travels through the acid and it adheres to the fastener, and then when it's done you can take and polish it, and it polishes up real nice. So you can see I have a nice polished bolt, and I want to do this because ARP doesn't make chrome fasteners and 6-point bolts for heads. So that's what I had to do with these bolts. These happen to be ARP 154-3603. That's the kit number on this one that I'm using for this. It's a 1/2-inch bolt, and it's just a straight torque bolt. Now, the question about whether or not to use lubrication on a bolt, and the answer is this. If you buy a bolt like these ARPs and it comes with the lubricant, always use the lubricant provided with the fastener. The lubricant goes on the threads, It goes underneath the head and on the gasket, or underneath the gasket and on the washer, and that is to provide a smooth and even torque as you're running it down, to provide an even clamping load through all the fasteners. Do not use motor oil. If you use motor oil can compress and it'll give you unequal or uneven clamp loads throughout the rotation of the bolt. So as more as you turn the bolt and clamp it down, the oil is going to push out of there and it will eventually grab, and you have a chance of a little galling there, and you'll get inconsistent clamp load. So always use the lubricant that comes with the bolts. So that's a quick rundown about head bolts. Also, even if you have a head bolt like a Chevy engine where the head bolt passes through a coolant passage to hold it down, you want to replace it because the coolant can erode or corrode the shank of the bolt, weaken it, and break eventually. So always replace the bolts or the studs, head studs, depending on what you're doing. And if you want to dress it up a little bit, you can polish it with, like I said, I use the Eastwood electroplating system. And no, Eastwood doesn't pay me to endorse their products, but when I do find products that work well, I like to share it with other people because people always ask how I get certain finishes on different kinds of metals. So let's put these head bolts on and torque them down so we can finish our head installation. Okay, I got all the bolts in. They're all run down kind of finger tight. I used my quick rundown wrench to get them all sort of tight. And when you do this, you want to follow, if you buy the cylinder head, you always want to follow the torque sequence that's recommended by the manufacturer. If you do not have a torque sequence that's specified by the manufacturer, always use a crisscross pattern, which means go up, down, over here, over here, over here, over here, over here, down here. Use a crisscross pattern from the center working out so that the clamp load is applied evenly throughout the head. Also, if the manufacturer specifies, it might specify to start at 30, go to 60, and then go to final torque. These don't have that. It didn't specify. However, I have to clamp these down to 100 foot-pounds. And I'm going to do it in stages. First, I'm going to start with 30. Then I'm going to go to 60, then I'll go to my final torque. And I'm going to do it in a crisscross pattern. I'm going to start in the center here to 30. I'll do my top bolt here. Again, working in a crisscross pattern. Up here. And a good tip for this is, if you want to make sure you're getting all of them, and you don't want to worry about missing a bolt, count them. If you have 10 fasteners, count to 10. Count each one as you're torquing it, so you make sure you get them all. You don't want to miss a fastener, that's a bad thing. Even clamp load crisscross pattern. Okay, that's the first stage. Let me go through the rest of both heads and I'll get them all torqued up to 100 foot-pounds. Okay, there we go, 100 foot-pounds all the way around. Now that we got that done, we can put in, let's see, next we're going to do the lifters. We'll set the push rods in place and we'll start to put our adjustable rocker arms and our adjustable push rod guides in place. Okay, installing your lifters is fairly easy. These are roller lifters. You don't have to worry about lubrication as much with solid lifters, but you do want to lubricate the outside, the bore, and the face if it's a solid. On a roller lifter, you want to make sure you get lubrication inside the bearing, inside the needles, and pack it in there. Pack it in there much like you are packing a bearing. You know, rotate it, pack it, get it in there. Make sure that you got a lot of lubrication, assembly lube, inside the needles, inside this roller, because once it starts up, you want to make sure you have adequate lubrication. And then you just slide these right in there. Of course, you use two hands, is a lot easier. These slide right in. Now, this item right here is called a dog bone. Although it's not shaped like a dog bone, it's referred to as a dog bone. And what this thing does is prevents the roller lifter from rotating as it sits in the engine. Obviously, you don't want this lifter here, if I take this out and you got this roller here, you don't want this spinning around sideways because that roller will act like a broach, and it'll chew your cam up in 2 seconds. So this dog bone, or this little tie between the two lifters, holds them straight and prevents them from rotating in there, in the bore, while the engine is running. Now let's put the push rods in, and I'll kind of put the guide plates on at the same time. You know what we'll do first? First, let's put on the rocker arm studs, because there's something you got to keep in mind when you put your rocker arm studs in right before you torque them down. So let's go to rocker arm studs. Okay, so here is my rocker arm stud and my adjustable guide plate. And the adjustable guide plate is for the push rod. Here's a push rod for the valve right here. The adjustable guide plate goes right on top, and the reason it's adjustable is because you move it back and forth to make the rocker arm sit right on the center of the top of the valve. Now the reason I wanted to show you this, and what's really important here, is sealing the threads on this rocker arm stud because of this. I'm going to take a flashlight and I'm going to go into my intake port here. I just got a regular flashlight. I'm going to shine this into my intake port, and if you see this, see that flashlight? I'm in the intake port, and the thread from this rocker arm stud goes straight through and dumps right into the intake port. So if I don't seal these threads for the rocker arm stud, and if I don't seal the face of this insert against the guide plate, oil has a chance of leaking down through those threads, leaking down through that insert, getting into the intake, sucking into the engine and burning. So you have to seal the threads. Seal your threads and seal the face for your guide plates. The threads for the rocker arm stud, and the face plate, the face of the plate for the adjustable guide plate. And I'll show you how I'm going to do that right now. Now I'm going to be doing a bunch of things at once here. And it's very difficult to film, but I'm going to explain it as I'm doing it. And this is what's going to happen. First, you'll notice I got these caps on here, and these are called latch caps. A latch cap is very simply a little hardened cap that sits on top of the valve. Now and it's got a little hole in there for oil to keep it lubricated. Now you might not need these, but this is what I found. And I'm going to show you one of the rocker arms. We'll talk about rocker arms in a few minutes. But when I put my, I'm using 2 different ratio rocker arms, okay? On my exhaust, I am using a 1.6, and on my intake I'm using a 1.72. Okay, 1.72. When I put my exhaust, and let me take this stud here. I'll take another stud and sit it in here. What was happening is when I put my stud on here and lined it up, and when I was sitting in here, the underneath of the rocker arm was rubbing on the cap. The valve cap, the spring cap. It was rubbing on the bottom, and I'll turn it over and show you. You can see that little rub mark. See this little rub mark right here? That little rub mark means that the angle, or this is so flat here, that this part of the rocker arm right here was rubbing ever so slightly on the corner of the cap, the valve stem cap. So I had to raise. There's one of 2 things you can do. You could either get shorter rods. Now if I get shorter rods, it's just going to bring it closer, or longer rods would take it further away, or I could just put latch caps on there, and latch caps are, either way, you can do it either way, and I've used latch caps all the time. So now with this latch cap on there, it lifts up the valve and it pushes the bottom of the rocker arm further away from the cap of the valve, and now it sits fine without rubbing on the surface of the cap. So this is what I'm going to be doing all at once, and I'm not going to film it because it's a very tedious process, and it's hard to follow. But what I'm going to be doing is kind of this. I'm going to put the right stuff. I'm going to put the sealant on the threads and in the hole. Then I'm going to put it on the face of underneath the guide plate. I'm going to start to torque it down. These get torqued down to 75 foot-pounds, but I'm going to torque them down to about 15 or 20 just to get them in place. Then I'm going to put my rocker arm on here, and I'm going to set it, and I want to move it till I get it kind of, when I make sure that I get the rocker arm in the middle of the valve stem. I want the roller of the rocker arm right in the middle of the valve stem. So I'm going to do that to get them straight, knock them around to get them straight. And once I have the entire engine completely lined up, or actually do one side at a time. Once I get the whole side lined up, I can take this off, make sure everything's torqued down correctly, put them all down all the way around the engine, rotate the engine 2 revolutions to give the valves a chance to work. Then I can come back and make sure they're aligned. Once they're sure they're aligned and they're all fine, I can take off my rocker arm, put a final torque on my stud, make sure nothing moves, and then we'll come back and talk about the rocker arm and the ratios. Here's what the process looks like. I got my studs in place. There's a lot of RTV or a lot of stuff coming out of there, but I'll just get it off later. So I got it kind of finger tight, kind of pretty tight. Everything's lined up. What I'm going to do is I'm going to put my intake rocker on, and I'm going to take it and I'm going to line up the bottom of the, kind of get it straight so that the roller's on the center. I'll take my exhaust one, put it on there, and adjust the plate a little bit. Make sure that it's in the center. That's going to stay there. So those look pretty good. This one can go over a little bit more. Adjust that one just a little bit more. And grab the light. Always use a lot of light to make sure you're in the middle. Okay, on that cap, good. Center of that cap. Okay, good. Now I can take these off very carefully. Take this one off very carefully. And I can torque down my studs. The important thing is to make sure your guide plates don't move and your push rods don't move. Got to keep all that as straight as possible. That's what holds your push rod from moving around, rattling when your engine's running. Torque those down, 75 foot-pounds. I'll do the rest of the engine. Okay, all the rockers are in place. Everything's sealed. Rocker arm studs are torqued down. Everything's all sealed up, and I'm ready to set the lash. Now, I'm going to set the lash for hydraulic roller lifters. And it's pretty simple. What I'm going to do is I'm going to turn the engine over, and as I turn it over, I'm going to be doing this valve right here. You're going to see, as I open this up, as I turn this over, you're going to see the intake valve open, and I'm going to let the intake valve open. And as the intake valve is going to close, and now the exhaust valve is going to open here. Now the exhaust valve is going to open, and it's going to come down, and right before the exhaust valve closes, I'm going to set the lash on the intake. And it's as simple as, I'll do it on this side, I'm going to take the play with this, and I'm going to tighten down my rocker arm nut here, just until there's no play. See, I got play, and now there's no play. And after the manufacturer, these are Scorpion rockers. The spec is till there's no play, and you take it and you turn it 1/2 turn. So I put 1/2 turn on it. Now, I'm going to continue to turn the engine over. Now you'll see the exhaust valve close, and right when the intake valve starts to open, I'm sure my exhaust is shut. So I'll do the same thing here. I will get all the play out of it, like that. Put this on there. And give it 1/2 turn. Then all I have to do is tighten up these end caps. Now let me show you how you would set lash for a solid lifter, solid roller, or I'm sorry, a solid lifter, solid tappet cam. Even though this is a roller lifter, I can still show you how to set the lash for a solid. So what you do is the same process. You get the valve so it's on the downside, and let's say it's a 5,000. I have a 5,000 shim. You put a 5,000 shim in there. You crank it down until you got 5,000 tappet clearance like that. See, I got 5,000s, 5,000 slips in there, and there's your 5,000s clearance. You can feel the 5,000s. You got your 5,000s clearance, and then you lock it down right there. That's the difference between roller and solid lifter tappets. That's it. Now everything's all done. I can go through and hold these in place and tighten down the Allen cap in the end that holds the adjustment in place. Now all the rockers are adjusted, and I turned the engine over several times and went through each one to make sure that each one of them is in the center of the valve. Went all the way around, did that a couple times, made sure it's right. Sometimes it does take a couple times. It's It's a little frustrating sometimes when you have the adjustable guide plates, but that's the way it is. Also, a couple things here. You can walk around and do a quick check when you're done. All of the set screws and the studs that hold the rocker arms down should be roughly the same depth. Actually, they should be very close to the same depth. If they're not, you might want to take a look at that because you might have set that one differently. So just take a quick look at that. Also, one thing I want to point out, if you recall, I was talking about the alignment of the oil hole. When the heads come from the manufacturer or when from Racing Head Service, the holes inside the head, and where they're cut for the oil return, are very sharp. They're sharp corners. And I want to show you what I had to do here in order to get this to run. I'm going to put some light on there. See how that hole is there? I sort of had to hand grind that squareness down and blend it into the head so that now as the oil comes and runs along here, it'll come here and run down that return a lot faster. This was the problem here. The runner and the return was really square right here. Oil was building up. It was filling up to here. It was flooding the seals, and I was getting oil in the intake. So take a look at that. You might have to chamfer your oil return hole just to make sure you get an even return and your oil gets back to the block and then into the crankcase as easily as possible. I think that covers everything. We installed the heads, talked about head gaskets, and we did our rocker arms, studs, adjustable plates, and that should be about it. So there you have it, guys. Everything about installing cylinder heads. Choosing your gaskets, measuring your head deck clearance, bolting up your heads, head bolts, push rods, push rod guides, lifters, rocker arm studs, rocker arm adjustable plates, guide plates for push rods, getting your lash set for solid, lifter tappets and hydraulic rollers, and finishing up making sure you're locking down your studs. And a couple extra things there to check along the way. I hope this helps you out. If you have any questions, I'd be glad to answer them for you. Thanks everybody who's been watching this video series. It's been very, very successful. Everybody's had some great comments, and I'm trying to use as much technical information as possible, but I'm trying not to go too in-depth. But if you do have a more in-depth question, I'll answer the best I can. And I really appreciate you watching this series. Thanks for all your comments. It's really great to hear everybody is enjoying it and learning something, and I learned something from your comments. So please make comments if you notice something. If I missed something, hey, I'm always learning too. I appreciate you watching all my videos. Thank you very much, and thanks for stopping by Pete's Garage.